I can. All right, so let me just grab the homework really quick for this assignment. What number were you working on?
Just the first one.
Okay, so you're okay with entering the data and putting it in your list, or is it before that you started having problems?
I believe like on the meal cost, I'll put it on line 1, and then the tip I'll put it on line 2.
Generally, the first, I have to take a look at it because I don't remember what it looks like, but generally the first line is X. So, let me see if I can. 8, 9, 10. 8, 9. No, wait, this is too far because she introduced chapter 10. There it is. Scatter plots, regression lines, and then here's the homework. Let me grab that and just download this. So when you do when you're doing the scatter plot here, let me share screen. Oops. So we're going to do this here, and it's gonna be, there's my data. So yeah, generally, like I said, the top line is your X, the bottom line is your Y. So make a scatter plot of the table above. So my X's, let me write these out. 475, this is 475. This is 684, 1252, 2042, and 897. And then we have 50 cents, 90 cents, $53, and $1. Okay. All right. So what we're going to do first is grab the calculator right here, and I'm gonna see if I can do a thing here and move. I'm not sure what I'm sharing. So let me see if I can find a window that has, okay, it has both of these in there. So, I'm gonna go ahead and go to stat, go to edit, enter here, and go ahead and put your X's in L1, which is the first, this is the first list. I'm gonna have to put this over a bit so I can see, okay, there. I'm gonna sneak this over here so I can, there we go. Now, so I have 475, enter. I have 684. And I just realized that my captions are not on yet. Let me fix that and show and start. Save that. Okay, and then I'm gonna do enter. And then I'm gonna say 1252. And 2042. And 897. And then I'm going to do the Y's in the same, so this is 50 cents. I'm just gonna do 0.5, enter. I'm gonna do 0.90. I'm gonna do $1.50. $3. and $1. Now, once you get here, this is your data. So what we want to do is we want to go ahead and plot the data, okay? You want to check first, check your y equals here. Make sure there's not a graph in here, like a linear equation or something else. If there is, remove it because you don't want that right now. I did because I want to show you this in parts. What I'm going to do is I'm going to, you see how it has plot 1, plot 2, plot 3 at the top? I
Yes.
want to get up there. So I'm going to hit the up arrow key. I can go there. I can do it like that. Okay. And then hit enter. That's one way to turn your plots on. The way that's in the instructions, I'm going to turn it off temporarily. The way that's in the instructions is to go second here and stat plot on the y equals key right here. Okay. What this is doing is turning on and off your statistical plots. We'd like to turn one of them on. So you can hit the enter key here and notice the on is blinking at you. That just means you want me to turn on? Yes. To tell it yes, you hit enter. So either way, you can do it. You can turn it on either way. We want to turn on the scatter plot, which is this first option. It's defaulted to that, so leave it there. Your X list is in L1, your Y list is in L2, so that works. You can change the mark to whatever you want, but we suggest using this first one. It's the largest and the easiest to see, okay? So far, so good. Are you with me here?
Yes, I am.
Okay, now, what students usually have trouble with is setting the window here, okay? Sometimes if you hit graph, if you go ahead and hit graph right now, my graph looks like this based on the wind, which is not a great window. I'm not seeing all my dots. There's a couple of things you can do. You can go to window here and set the window manually based on your data. And you can say, well, gee, my L1s, my horizontal top list here, go from 475 to a maximum of 2042. So you could start your X minimum at like 1 or 0 if you want. And then you could set your max. You want to set your max slightly above where you are. So maybe like 25 and scale this by 1 unit. This is X scale. Now you could scale this by 2 units. You could scale it by 5 units. I'm going to scale mine by 2 units, for example. Now the Y coordinates go from a minimum of 50 cents to a maximum of $3. So I'm going to say that I'm going to go from, say, I don't know, let's do 10 cents. So I'm going to do this at 0.10. My maximum at a little more than 3, so maybe 350, let's say. And we're going to scale this by, maybe we'll scale this by, let's see what we do with 20 cents. Let's see how that works. And then you graph it. And notice now I can see the whole thing, okay? Now I just wanted to do an example of setting your window manually. You can also use the zoom key here. You can use the zoom key and you can use option. For me, there's a whole bunch of stuff down here, but you can also use zoom stat. If you want to use zoom stat, that's a really quick way to get a window. It's slightly different than the window that I just set, but zoom stat will give you a window that automatically fits. Okay, this is your scatter plot right here. Okay,
Okay.
now that's your scatter plot. It doesn't include your regression line yet, but this is your scatter plot. Now, sometimes what students tell me is, okay, but I don't know how to trace that onto my, all you're doing here is plotting these points. So literally this is X, Y, but if you forget where they are, one thing you can do is hit the trace button and it will show you where your points is. Okay, so to continue that, you can just use the arrow keys and it will show you the coordinates of the points that are plotted. So if you want to do that, you can do that. That's how you copy that. You literally have to plot these points by hand to copy that. Now, the next thing it says is find the linear regression equation in the form y equals mx plus b. So what we're going to do here is we're going to let the calculator do the work, okay? And the way we do that is we go to stat, we go to calc, we right arrow one time to calc, and we're going to go to, now I'm going to show you here because this gets confusing for students. There's a linear LIN reg AX plus B and LIN reg A plus BX, okay? They're both linear regressions, okay? The difference is the format. If you look in parentheses, the format is different, okay? We want to use number 4 because that's closest to what we're used to. We're used to mx plus b from algebra. We'd like the x term to be first, and we'd like it to be associated with a. The difference in A is that A doesn't have an X next to it, B does. What they've done here is they put the y-intercept first and they've made B the slope, which is something we're not used to. But you're going to use option 4 here. So you can either go to option 4 on the menu with the arrow keys, or you can type the number 4 and it will take you there. Okay. X list is in L1, Y list is in L2. We're not going to worry about the frequency list. We're not going to worry about storing the regression equation anywhere. Okay. We're going to calculate this. Now, I left this way for a reason. If your calculator looks like this, you do have the regression equation, but you will need the coefficient of the regression coefficient, the Pearson, all that. So the way you get that, if your calculator looks like this, does your calculator look like this?
Yes.
Okay, the way you get the other two values, because the next thing she wants is oh no, she doesn't ask you to find R for, oh yeah, what is R, the correlation? Okay, so to get R, we're going to go into our catalog of functions. Catalog is on top of the 0. So we're going to go to second catalog here. And believe it or not, this thing lists all the functions that your calculator does in alphabetical order. Okay. So if you're ever curious about, can my calculator do that? You can look here. But there's a function called diagnostic. And we have 2 of them. We have one to turn it on and one to turn it off. We want to find diagnostic on. So what we're going to do is we're going to take a shortcut. Rather than scrolling down all the way to the D's, we're going to use the alpha key here. It's below the second key. Use alpha. and then find the letter A. A is on top of the math key. That's your alpha. Now go to D for diagnostic. So alpha, and then D is on top of, oops, I got off the wrong page. So second catalog right here, then alpha and D for diagnostic. So if it doesn't do it, it should do it. There we go. You might have to do it twice. I had to do mine twice. Now use the arrow keys and scroll down until you find diagnostic on and put your arrow next to it. Turn it on and hit enter. You should see diagnostic on pop up on your screen, and you should see the cursor blinking next to it. Now hit enter one more time until you see done here. Okay.
Okay.
Okay, now we're going to go back and repeat just the last step of what we did. So we're going to go to stat. We're going to go to calc. We're going to go to 4. Stat calc 4. I'm going to go to calculate. Now watch what happens here. Notice that now I have 2 additional values down here. Okay. Now, one thing, you don't need to worry about turning your diagnostic off. Okay. If for some reason you go through it and you don't see it, that's the procedure that you do. This should stay this way. Like you should be fine to turn your calculator off, do whatever. If you change the batteries or if you reset the RAM, this will default back to just A and B. So you'll have to do that procedure again to see it. Okay, so just to let you know that. Now, how are we going to graph the regression equation? Well, A and B are the regression. If you remember, I'm going to put a text box here. If you remember here, we have y equals ax plus b. So what we're going to do is we're going to copy that, write this down on your paper. We're going to round this to 4 places. So we're going to write y equals, and we're going to, so A here for me is 0.1569. So I'm going to write 0.1569, and remember your x, okay, plus, in this case, it's minus. So I'm going to put minus there because it's a negative. B is negative. So I'm going to go ahead and use the minus. And I'm going to say 0.2992. So this is 0.2992. Okay. That is my regression equation. Okay. What I'm going to do, because I want to graph my regression equation with my scatter plot, right? So I'm going to go into the y equals screen. Now I'm going to hit the y equals key above second, okay? Just the y equals key. And I'm going to input what I just minus the y. I have the y already. So I'm going to write this 0.1569x minus, oops, I have 2 x's there, delete one of them, minus 0.2992. So I have 0.2992. Now hit graph and watch what happens. Okay, your scatter plot was already there. The boxes were already there. All it did was superimpose or write over the line. This is your scatter plot with your regression line intact. And remember, you can use the trace feature if you want to see which points are closest to the line. It looks like the points closest to this regression line are 4.75 and 0.5 and 6.84 and 0.9. Okay, this is a fairly close correlation. All right, so that's your,
That's for like answer C, like graph the linear regression equation.
okay, the linear regression equation is just the boxes.
Okay.
And then the equation is the line itself. So the scatter plot, let me clarify, because that's a really good question. So I'm going to turn this off for a second. I'm not going to erase it. I'm just going to turn it off. So if you remember when I graphed this is the scatter plot. Okay, this is called the scatter plot. So if I add the regression line into it here, then this graph here becomes the scatter plot, the boxes, with the regression line or the line of best fit. So A says make a scatter plot, which is the boxes, okay? And then B says find the linear regression equation. So this is part B right here. This is part B, okay? And then it says, what is R, the correlation coefficient? Now, I didn't write that down, so I'm going to have to go back. Stat. So I forgot to admonish you to write that down. So I'm going to say, but it's not a big deal. I'm just going to go to stat calc 4 here. And there's my equation right there. My regression coefficient, my R, the correlation coefficient. So this is also part of part B. Okay, what is the correlation coefficient, right? So your correlation coefficient is R, which is equal to 0.9911. Okay, so what she's looking for in C, by the time you get to part C, what she's looking for is a graph that includes both of these. So in part A, you're graphing the dots. Then you're getting your equation of your line and your regression coefficient, and you're putting your line on top of your scatter plot, essentially.
Okay, I get it.
Okay. Then it says, if the next diner orders a meal costing $10.50, how much tip should the waiter expect to receive? Okay, so to do the predictions, it's really helpful when you do your regression equation. I'm going to skip to part D over here. So when I'm doing my regression here, I'm going to rewrite my regression equation. 0.1569x minus 0.2992. Okay, this x is the meal cost. So make yourself a note that let x be the cost of the meal and y is the amount of tip that you're going to receive, right? So let y equal the amount of tip. Now, why did I do that? If you do that, if you take the time to label this verbiage, then when you have an equation like this, it says how much if the next diner orders a meal that costs $10.50. Okay, so X is $10.50 because that's the meal cost. So this is $10.50. Now, the reason I point this out is she doesn't have to give you X. She could give you Y and tell you to find X. But here she gave you X. X is $10.50. And how much tip do we want? Y is question mark. We don't know that. But we have this equation here. So what I can do is I can say, well, okay, so Y equals, and I'm going to put it in there. So this is 0.1569. And I'm going to replace it with my meal cost, which is $10.50 minus 0.2992, like so. And I can go to the calculator at this point. Be sure that you quit from your, sometimes students don't know how to do this. Usually, anytime you're in a screen, you don't want second quit or second mode is a good option. So second quit gets us back to our home screen here. And then you're going to just do 0.1569 times 1050. Whoops. Nope. What is all that? Hold on. I got a few things I didn't want. Okay. There we go. 1050. And then I have minus 0.2992. So my tip, remember this is money, so go ahead and round it to two places. This is going to end up being $1. Oops. It's going to end up being $1.35. So if the meal cost was $10.50, based on this model that you have, you would expect a tip of $1.35 as your answer.
Got it. Thank you so much, Shauna.
You're very welcome, Mauricio. Nice
All right,
to
have-
see you.
Have a nice evening today.
You too. Thanks.
All right. Good night.
Okay, so that was the homework for 10.2, number 1. Now I'm going to go back and show you something else from another set of homework. So let me do some house cleaning here and pause the recording temporarily while I do so. What I'm going to do here is switch gears and go to section 7.4 and show you some things from there. So here we have the slides. Let me show you that. So confidence intervals for variances and standard deviations. Okay. The first question of the homework asks you comprehension questions. We always have those. What distribution must be used when computing confidence intervals for variances and standard deviations? If you don't know, then you can and you should I strongly encourage you to go ahead and look at the slides. So we're going to look at the slides here for a moment. And this is our, now look at the first bullet. The chi on slide 2, the chi-square distribution must be used to calculate confidence intervals for variances and standard deviations. So the distribution here that you're going to use is chi-squared. Whoops, wrong homework, sorry. Is the chi-squared. So this homework for this answer, you're going to write chi-square. This is the chi-squared distribution, okay? Now, using the table, we're not using tables. If you're comfortable using tables, you can, but we're going to use, you've got some options in this section. Those of you who are taking the class online, you have lots of options. You can use the link that she provided to the chi-square distribution chart, which also has the t-distribution, the normal distribution, and the f distribution, as well as chi-squared. But you can also use the calculator program. Those of you who are in a lecture class, she's not going to provide the tables or the website link for your exam. So you need the program, and she has provided the program for you, as well as a video that you can watch. I'm going to try and go through it right now. It is quite labor intensive. It's not hard. It's just a lot of details, and it's not a long program, but I want to make sure that you see that. So what I'm going to do now, before we come back to the homework, I'm going to attempt this. And I'm going to see what happens. So I'm going to close a few things here on the screen. Let me stop sharing here and try and drag the program and the calculator into the same window so that I can help you see that. So we have the whoops, not what I intended. Okay. There's my, okay. So now I should be, let's see if I am. Am I sharing the same screen? No, I'm not. Just, let me see this. Okay. I want to make sure that my window has both things in it. So I'm going to new share here. Okay, this is your screen. And we should be able now to see both, I'm hoping. This is my now. On the slides, she gives you, as usual, the properties. You can see chi-squared. We're going to come back to this formula in a little bit. But before we do that, and before we talk about finding coefficients, I'm going to take you through the information needed to program the TI-8384 calculator. So I will take you through that. If you have, my emulator is set to 84 plus. If you have an 84 plus, CE, you'll have one extra step here, but we're going to be working with, excuse me, we're going to be working with the program key, which is the third line of major keys in the body of your calculator. Program is right in the middle under stats to the left of apps. I'm sorry, to the right of apps, to the right of apps, to the left of VARs, program. We're going to be working with that. Let me show you the program that Professor Nickdell has given you. Okay, so what we're going to do, this program is on slide 8. Okay, so what we're going to do, and I'm going to do this in real time, which means I'm going to be really slow. So if you already know some of this, you know where I'm going, feel free to go into the settings of this video, the settings gear on the bottom of the video, and put it on a different speed, okay? Feel free to do that if you'd like. I'm going to go into program here, and there's nothing here right now, right? Because there's no programs. What I'm going to do is I'm going to create a new one. So I'm going to go to new. So I right arrowed twice to new. I'm going to go to create new, and I want to create new. So I'm going to hit enter here. And then it's going to say name equals, and I want to name it, okay? I want to name it INVCHI2. You can name it something similar, but I'm going to stick with this. This stands for inverse chi-square, okay? So to get your letters, if you notice on my calculator, I have blue functions on top of most of the keys. I also have some green letters, green uppercase letters. To get the green uppercase letters, we're going to use alpha. So what I'm going to do is I'm going to hit alpha here, make sure that your little A is blinking, and then you want to hit the letters. Now I is going to be, your letters go in alphabetical order, starting above the math key, and they go left to right in alphabetical order. So I is on top of the X squared key. So that's I. N is down below that. So we got alpha. Okay, now what I'm going to do here is I'm going to do alpha and my N. So N, and I need the V. So that's going to be alpha. V is going to be on top of number 1. Oops, excuse me, wrong letter. Going to be on top of number 6. So, but I need the alpha. So alpha, and then the number 6, INV, then alpha, then C. So C is going to be above the program there. Alpha, then H. So H is going to be above the caret here, and I, alpha, and then above the square root, INV, chi, and then to get 2, we just hit the number 2. That's the name of it. Anytime you finish a line, you hit enter. And you get a little colon here. That's telling the calculator's telling you I'm ready for more information. So you've just started a program called INV chi2, or inverse chi-squared. Now the next line says input equals, and then it has some information there. So to get to any of our program functions, we're going to go to program. Now, we have control functions for those of you who know something about program that control the functions of the information. Then we have IO next to it. So I'm going to right arrow one time to IO, and the first option on that list is input. So I'm going to hit enter here, and it's going to say input. Then I'm going to need quotation marks. Quotation marks. The quotation marks are okay, so let's see. The quotation marks. I have brackets and I have it's above it's the green ones on top of the plus sign. So I'm going to go alpha here, and then on top of the plus sign right there. And I'm going to then type area right. So I'm going to say, now something you can do to speed up the typing so you don't have to hit alpha every time is you can go second A lock and it'll lock your alpha until you're done here. So A is going to be on top of the math key. So we're going to hit that. R is my next letter. So R, this is R here on top of that. Then E. Now don't hit the E, that's the E for enter exponent. Don't hit that. We want the letter E, which is on top of the sine curve, okay? Then another A right there. And then we want a space. Space will make it look nicer. And so to get the space is actually on top of the catalog key, on top of 0 right here. And it just moves it over for you. And then type right. So right is going to be, let's see, R. So that's L, let's see, R, D, E, F, G, H, I, J, K, L, M, N, S, T. R is on top of that. And then right. So we have I is here. G is here. H is here. And T is, don't worry if you go over, just keep typing, okay? Because the program will fix that for you. Now, area right, and then we're going to use the colon. You find the colon on top of the period at the very bottom between 0 and the toggle minus. Hit the colon here. And then you're going to use the quotation mark. And remember, the quotation mark was on top of the plus signs. That's area right. Okay. Then before you close it, you're going to use the comma. The comma, now we want to turn our alpha off. So I'm going to just hit alpha again. And now you're back to regular letters. Turn off your alpha. Take your comma, we're familiar with where the comma is, and then letter A. So I'm just going to hit alpha, not alpha lock, just alpha, and then A. Okay, right here. And that is the second line of my program. Input, quotation mark, alpha lock, second alpha lock, actually. Then area right, colon, quotation mark, comma, A. All right. I'm going to hit enter to tell it that I'm done with that line. And then we're going to get input again. So we're going to go program, We're going to right arrow one time, IO. We're going to input. This time it says input, and we're going to do degree of freedom. So we're going to use the quotation mark here. So this is going to be our alpha with our plus sign. And then we're going to put DF in there, input DF. So we're going to use our alpha and our D, which is this, and cosine. Whoops. You know what? If you make a mistake like I just did, no big deal. Just backspace over it, not the D, but the cosine, and just delete it, okay? Then you need another quotation mark. So we need an F though first. So alpha, and then F. DF, and then we need alpha and quotation mark, which is on top of the plus sign. And then we're going to, but before I do that, I missed a symbol. So let me go back. This is a colon. So we're going to do alpha, and then the colon is on top of the period. Then we're going to do the quotation mark. So alpha, quotation mark, alpha, quotation mark. Okay. And then we're going to hit the comma key, and then we're going to hit letter D. So alpha and D right here. Then we're going to, we have one final line. So here I'm going to hit enter again. We have another line. So we're going to use display. All right. So display is going to be program, and it's under IO commands. And you look, make sure it's disp, not any of the other disps here. There are 3. You want the plain one. This is number 3. Hit enter. Disp, and then what do we want to do? We want to display solve. This could look a little different on your calculator, and it's a little bit hard to find. Solve is on the math menu. So we're going to go to the math menu here, and solve is pretty much at the bottom. So I'm going to use a shortcut. I'm going to hit the up arrow key, and it'll take me to the very bottom of my list. Some of you might have some additional options down here. Make sure you're on solve, okay? Solve is where you want to be. So hit solve. Then we have to do some other manipulations. So we're going to do 1. We know how to do that. Minus. Use the minus key next to 6. Now we're going to put in the chi-square function. And you say, how do we do that? We go to where we would normally go for a chi-square distribution. So this is second distribution. Go to your chi-squared. So second distribution, chi-squared CDF, number 8. Okay. Number 8 for me. Make sure it says chi-squared CDF. Hit enter. Okay. Now, these 3 elements that you see in parentheses are your lower, your upper, and your DF respectively. So your lower is going to be 0. So I have 0 there. So leave that. Your upper is going to be X. Now, use the X that's next to the alpha key where you have X, T, theta, N. Use that X. Okay, that's that X. Your DF is going to be letter D. If you remember the program, we made that a variable. So we're going to use D alpha. Anytime you want to enter letters, alpha and D. The only exception to that was my X on the X key, the only exception to those letters. So alpha and then D, which is my matrix keys. And then we're going to down arrow to paste, hit enter to paste it, and we have display solve, open parenthesis, 1 minus chi-squared CDF 0xd. Now we're going to go minus, this is the regular minus, next to 6, and then we're going to type some other letters. We're going to type A, so remember, alpha, A is above the math key, A, comma, X is xt theta n, and then comma, and then 0. That's not the letter O, that's 0. So we're going to put 0 there. Close your parenthesis. The closed parenthesis is up above number 9. Close the parenthesis, okay? And we're done with that line. Hit enter and leave the colon, okay? You don't have to save your program. Your program will stay saved as long as your batteries don't die and something magnetic doesn't get, it will stay saved, okay? What I'm going to do now is I'm going to show you how to use this to get chi-square values, okay? I have to show you some things about the chi-square distribution, but this is the program we're going to use. Before I do that, though, I'm going to give you an example. We're going to go to the next slide, and she gives you a picture. So it says, find the values for chi-square right and chi-square left for a 90% confidence level or a 90% confidence interval when n is 37, okay? So we have, this is a 90% confidence interval, 90% confidence, and we want to find, and we know n is 37, okay? So we're going to need some things here, but the chi is going to help us get our values, and I'll show you what we need to do. I'm going to stop sharing temporarily so I can clean up my desktop. I'm going to drop the slide from here for a moment, and I'm going to reshare the screen because I want to bring up the, hold on, I'm going to have to move my Zoom screen here. So what I'm going to do is I'm going to move this up here, and I'm going to share the screen here, but I'm going to share the whiteboard so I can show you some things. So now this is my whiteboard, and I'm going to make my drawing. Now, the thing about the chi-square distribution is that it's right skewed, okay? It's right skewed. So it doesn't really have that little mark on the end, but just ignore. So here, I've got my chi-squared. Let's say that my chi-square left, let's say that that's this value here. So this is chi square left. This is chi square left. Now, I want to point out something here because chi squared, we saw that it was skewed, okay? But I want to point out something. The chi-square distribution, and this applies in your calculator as well. You're going to use the area to the right of chi-squared because it's a right skewed distribution. So if you're looking for chi-squared left, okay, the area that you're going to enter is all of this area on the right. We're not used to that. Normally we enter area here, but we're entering area on the right. So we're entering all of this. When we get to, let me temporarily erase this. When we get to chi-square right, we're going to enter, let's say this is where chi-square right is. This is chi-square right. I'm going to use the area to the right of chi-square right to enter that, okay? We'll go over it in a moment and you'll see what I'm talking about. But a little bit of housekeeping, we've done this before. If we know that my confidence level is 95%, confidence level's 95. Actually, I take that back. It's 90 for this example. 90. Alpha is 1 minus the confidence level. No matter what you're doing, alpha is 1 minus the confidence level. Alpha is 1 minus the confidence level. So that means alpha here, alpha here is 1 minus 0.90, okay? You need this number to be able to follow her instructions, okay? Alpha is 0.90, so I'm sorry, the confidence level is 0.90. So alpha here is 0.10. All right, so what we're going to do is we're going to find two numbers, chi-square right and chi-square left. Now, alpha is 0.10, keep that in mind. Keep in mind that your n here, n is 37. Just like with the t's, your df is 1 less than n. So df is 36. Okay, so if you're following along with the video, you might want to write these three numbers down. I'm going to go back to the instructions and I'm going to be using the calculator. So write these three numbers down. Alpha is 0.10, n is 37, and the degree of freedom is 36. Okay, so going to come back to the slides for a moment first. And we've done this, we've got our alpha, this is our 1 minus. I'm going to come down to the next one here. Now I want to get the program. So what's happening here is she usually gets chi-square right first. And that's because chi-square right is the first thing that comes in the formula, okay? We'll explain the formula in a moment. Let me go back to this, whoops, let me go back to this slide here, number 4. If you look at the slide, we have n minus 1 s squared, which is the sample variance, over chi-square right is less than sigma squared, which is the population variance, is less than n minus 1 s squared chi-square left. This is not a mistake. Chi-square right is on the left side of your formula. Chi-square left is on the right side of your formula. Now, why is that? Well, if you think about chi-squared being skewed to the right, and that means that all of these chi-squared values are positive. This is chi-square left, and this is chi-square right. Chi-square right over here, chi-square right is going to be larger. So chi-square right is going to be larger than chi-square left. When I divide the top by a bigger number, the resulting quantity is smaller. So I want to be dividing because I want the confidence interval to go from the small number to the big number. So I want this to be the big number. So I'm going to use that on the left side. Now, the area to the right of this chi-square right is just alpha divided by 2. This is the area to the right of chi-square right, and that's alpha over 2. Okay, so what we're going to do here, I'm going to bring the calculator now. Bring the calculator, all right? Share the screen. Now, we just put in the program, so we're there. What I'm going to do is I'm going to quit from here and quit so that it's like a new screen for you. So let's say that you picked up this problem. I'm going to arrange myself one more time here. And I'm going to, okay, here's my screen. I'm going to look at the example here that she worked on. So we can do this example, make sure your program is working before you start doing the homework. So your chi-square right is inverse chi of alpha 2 and df. So program, and then once you stay on execute, don't move it. You're not editing it. You're not making a new one. You're on your chi-square program, hit enter. Program inverse chi, yes, hit enter. Area right, what is the area to my right? It's alpha over 2. What was alpha? Alpha was 0.10, so you can enter 0.10, the division sign, and then 2, just like you normally would. When you're done, hit enter. It's going to ask you for the degree of freedom. The degree of freedom here is 36. 36, hit enter. And this is your chi-square value, 50.9985. You're going to round it to 4 places, 50.9985. Now we're going to go and we're going to get chi-square left. So what I like to do is go ahead and run the program again. Program, inverse chi, enter, enter. Area right is going to be, for this one, we're doing the area to the right of chi-square left. So we're going to do 1 minus, remember alpha is 0.10, 0.10 divided by 2. You can also do this calculation and enter it as a single number if you'd like, but it will take the whole thing. Your degree of freedom is 36. Hit enter, and you get 23.2686. And that's how you use your program to find chi-square values. Now, I'm going to make one more switch. Now that you've seen that, I'm going to, now that we've actually talked about putting it in your calculator and finding the chi-square values and verifying that your program works, I'm going to now grab the homework here. I'm gonna stop sharing though and grab the homework. So let me do this. I'm going to maneuver the slides out of the way and grab the homework assignment and pull up the homework assignment here so that we can look at that. Because this is the good stuff, okay? It says again, using tables, we're not going to do that. We're going to use the program that we just programmed. So what I'm going to do here is make sure that I'm sharing the right screen, which I'm not. I'm not sharing the screen that I would like to. So let me figure out what I'm doing here. Open it. Okay. Well, what I can do is I'll bring up the homework first. This says using table G, find the values for chi-square left and chi-square right. A is for alpha equals 0.05 and n is 12. Now, she did you a favor here because she gave you alpha. Okay, remember when you're doing the confidence interval, you won't have that. She gave you alpha, she gave you n, not df. So remember, to get to your program, you go to program here, inverse chi. Now, if you want to do the area to the right of chi-square left, so you want to find the lower chi-square first, that is 1 minus your alpha, which she gave you, 0.05 divided by 2, like so. Okay. Hit enter. Now, your DF, your N is 12. That means your DF is 12 minus 1, 11. Hit enter. Now, your chi-square left is 3.8157. 3.8157. If I want to do chi-square right, then I say program inverse chi, enter. Now the area to my right of chi-square right is going to be 0.05 divided by 2. Hit enter. Your degree of freedom is 11. Hit enter. This is 21.9200. So this is your chi-square right is 21.9200. Now, let's check. So I'm going to scroll down to her answer key. 3.86 and 3.816 and 21.920. Okay, she rounded to 3. I took it to 4. That, I hope that helps. This is problem 2 from 2A. I didn't do all of the parts. That's 2A. But that's how that works. Now, I want to point out a couple of things. in the section here. When you're using raw data, like on number 3, you have to put the raw data into a single list and then find the standard deviation. If you want more detail on that, you can watch the embedded tutoring video from this morning where a student and I went through that, okay? But this is the end of this video. I hope it's been helpful to you. And I will see you for embedded tutoring or back on the internet for another video very soon. Thank you, folks. Have a safe evening. Bye for now.